review of problem number 7, cup drum. I'm Felix Engelmann from the German team. Then to the report, we heard a theoretical explanation which was quite on a high level. Then we heard something about the harmonic, which is important for the oscillation. He varied some parameters as a cup in length and form. He varied the frame thickness, which is important for the oscillation of the frame. And the most important parameter is the distance of from the water surface, because this is directly asked in the task and the most important parameter. But he also missed some parameters, as we think, which was the mounting. The mounting has also a big influence of the oscillation of the frame, or if you mount it on the frame, but it will be definitely a damping. So also the water level inside, there are two variations. If you have no overpressure inside and the water is close to the surface ending of the cup, or if the water level is the same inside and outside. This would make some difference also in the standing waves and the surface tension, but this he mentioned during the discussion. But what we think that there were two less measurements points and variations of these parameters, and what also is a big important parameter is the directional characteristic of the cup, because that's important to where to put the microphone, and also the reproducibility, which should be mentioned. So then, to the opposition, the opponent summed up the whole presentation really good. He mentioned the reproducibility of the results, which have an influence, as I said, and he also mentioned the mounting, which missed, and the position of the microphone, which refers to the directional characteristic. He mentioned acoustic impedance, which was quite good and important to an open-end sound pipe. Then the parameters, the material of the cup and the eigenfrequency, which we really appreciate, but he also missed some parameters as the water level inside and the surface tension. So then to the discussion, the eigenfrequencies were discussed, which didn't lead to a conclusion between the opponent and the reporter. Then they talked about the reflection of the sound, and the reporter mentioned that it's very complex, but he gave a qualitative explanation which was quite good. Then the modus of oscillation they discussed about, but they didn't rewrite it. So then the influence of the tapping was not varied. Only they talked about the position but didn't measurements on this, which might be important. Then also the speed of sound has an influence also on the impedance, and the opponent, the reporter said that there is an influence but not a big one, but we think this is an important factor. So to the water level inside, they both mentioned that it's not important, but I think that it is. And also the errors of the experiment, but then the reporter said that they are small and we have to believe this. Then to the overall impression, they did a good theoretical approach, and they varied the relevant parameters. They had a productive discussion which altered the problem to a higher level of understanding, so they fulfilled the task completely. Thank you for your attention.
Thank you for your review. And we have time for the concluding remarks. Okay, please start it now.
Before I begin some of the most important parts of my final remarks, I'd like to clarify and modify some of the points in the reviewer's excellent presentation. For sidewall vibrations, mainly the cup in my experimentation was held by 4 very strong metallic rubber materials and because of that, sidewall vibrations could be ignored. As the problem states, it says the cup has to be held. Thus, sidewall vibrations are inherently, from the problem statement, a non-important factor here. For directional components of the standing waves, you can actually see that I did consider some cases of equatorial resonance. However, these sounds were not really significant in terms of the FFT data, so that was also not included. For some of the pressure differences, that I actually calculated the rise of the height in the water, so those considerations were actually done in my experimentation. So at the end of the day, the presentation really comes down to what really is the physics lying and what's the physical significance of this problem. And, well, problem sub number 7's name is cup drum. So 4 basic sounds, I'm going to let you hear it first. And using that, let's see if we can make a combination. Ladies and gentlemen, what you heard just there, that is physics.
Thank you very much for the nice presentation, position and review. And now we have time for the jurors to pose their questions. Questions should be short and should allow short answers. Valentin, please use your mic.
I have seen some coefficients in your equations. How did you measure it?
Okay. So in your equations, the coefficients, what you used, did you measure them directly?
Alright, for the thin plate vibrations, there are remaining 3 coefficients, which were firstly the Young's modulus, second the Poisson's ratio, and thirdly the volume density. All were calculated as theoretical values that are already given for cases of plastic.
Okay, so just to be sure, you haven't fitted anything to your theory from the experiment. So there was no fit.
There is a fit for all the data for standing waves and thin plates. The black line was all the theoretical calculations.
Okay, thank you. Further questions? Samuel, please.
A question to the reporter first. Do you think that there's a difference if you measure the sound with the microphone within the cup or outside of the cup?
Generally, when you measure the cup outside the cup, the peak frequencies in the FFT data still will show a similar, actually an accurately same trend. However, in terms of the amplitude of the sound, the measurements can be different, varying in the location. But the frequencies, I believe, will stay the same.
And the opponent, do you agree with that?
No, definitely not. I think that if you measure amplitude of the sound outside the cup, you mostly hear the either frequency of the cup itself, not the frequency of the oscillating air inside.
Further questions? Please, Mahdi.
From the reviewer, please. You mentioned that the service station has been missed in presenting of the reporter and the opponents. Okay? What's your idea about how this parameter will make the rule in the problem?
Very short answer, please.
The problem says that you have to measure it on, below, and above the water surface. So, what is the on state? And if the cup is really near to the surface, then due to water waves on the surface waves of the water, there will be a connection to the cup, and then the whole characteristic will definitely change if the cup is a normal cup and has quite no mass. So this will influence the damping enormously. Are you angry?
Yes, I also believe, thinking it over again, that the surface tension variable might also influence the acoustic impedance of the different materials, especially for the case of water. But as my experimental data seems to show, that slight change in the impedance value is insignificant enough to ignore in terms of the theoretical calculations.
Okay, thank you, Swaminathan. Please pass the microphone.
My question is to the reporter. Tell me, what are the frequencies you had? The first and the third. What is the relation between them?
Alright, for the standing waves inside the cup above water, the frequency relationship from first to third is multiplied by 3.
Can you get the fifth oscillation? Fifth water?
The fifth is multiplied by 5 with respect to the first harmonic.
Thank you. Further questions? Samuel?
A question to the reporter.
Yes.
Did you only observe the fundamental oscillation of the base or higher order?
The plates.
Of the base of the cup.
Alright, I actually did 2 main observations. When the cup was hit with respect to its perfect cylindrical axis, then I was mainly only able to observe the first root of the Bessel function, thus being the first fundamental frequencies. If I hit other locations, I was also able to see other modes and other nth roots of the Bessel function. So yes, I was actually able to observe different frequency modes of the FFT. Thank you.
Thank you for your answer. Do we have further questions? Please.
Well, I have a short question to the reporter. Can you measure how much water comes into the cup when you put the cup?
Yes, I in fact did.
And also, where are your microphones located in each of your measurements? Because
Okay.
it goes microphone in and microphone out of the cup.
Okay, so try to give a
Yes, for plate vibrational frequencies, the sound sensor was placed near the plate itself. For standing waves, it was placed inside the cup for more accurate measurements. For measurements inside when the cup is submerged underwater, I placed a smaller microphone with wire inside the cup to measure the standing waves and raised the water cabinet like so.
Okay, thank you much for the answer. We used our time, so thank you much.
Thank you very much.